The moon, our celestial companion, seems cold and still. But beneath its dusty surface lies a secret. The moon is hotter than we thought. This unexpected heat isn't from the sun, it comes from deep within the moon itself. This discovery surprised scientists. How could the moon, a seemingly inactive world, generate such heat? The answer lies in the fascinating world of radioactive elements. Deep inside the moon, hidden beneath layers of rock, are radioactive elements like thorium and uranium. These elements are unstable. They break down over time, a process called radioactive decay. As they decay, they release energy in the form of heat. Think of it like a slow-burning fire, releasing heat for billions of years. This radioactive decay is what keeps the moon's interior warm, even after all this time. Now, you might be thinking, radioactive elements on the moon? Are they dangerous? It's a fascinating question that takes us on a journey through both the moon and our own planet, Earth. Well, here's the interesting part. The moon isn't the only place with radioactive elements. Earth has them too. In fact, radioactive elements are more common than you might think. They are present in the very ground we walk on, the air we breathe, and even in the food we eat. In fact, the natural background radiation on Earth, coming from rocks, soil, and even our own bodies, is higher than the moon's internal radioactivity. This background radiation is a part of our daily lives, and we have evolved to live with it. The rocks and soil on Earth contain elements like uranium and thorium, which emit radiation as they decay. So, the moon's own radioactivity isn't the biggest concern. When astronauts walk on the moon, they are exposed to much lower levels of internal radioactivity compared to what we experience on Earth. The real challenge lies elsewhere. It's the radiation from space that poses a challenge. Cosmic rays and solar radiation bombard the moon's surface constantly. Unlike Earth, the moon lacks a protective atmosphere and magnetic field to shield against these high-energy particles. This makes space radiation a significant hazard for astronauts. Spacecraft and lunar habitats need to be designed with special shielding to protect against this relentless cosmic bombardment. So while the moon's own radioactivity is relatively benign, the space environment presents a formidable challenge for human exploration. Earth is constantly bombarded by radiation from space. This radiation comes from the sun, distant stars, and even beyond our galaxy. Thankfully, Earth has a secret weapon. Its magnetic field, this invisible shield, generated by Earth's core, acts like a force field, deflecting most of the harmful radiation that comes our way. This protection is what allows life to thrive on Earth. Section 5. The moon's unfiltered radiation, a cosmic hazard. The moon, unlike Earth, doesn't have a strong global magnetic field. This lack of a protective magnetic shield means that the lunar surface is constantly bombarded by space radiation. Unlike our planet, which has a robust magnetic field and atmosphere to deflect and absorb much of this radiation, the moon is left vulnerable. This means the lunar surface is constantly exposed to the full brunt of space radiation. Cosmic rays, solar wind, and other forms of high-energy particles relentlessly strike the moon's surface. These particles can penetrate deep into the lunar soil, creating a hazardous environment for any future explorers or settlers. This radiation is a serious concern for future lunar explorers. Without proper protection, astronauts could face significant health risks, including increased chances of cancer, damage to their central nervous system, and other radiation-induced illnesses. The challenge is not just surviving the journey to the moon, but also living and working on its surface. Imagine standing under a waterfall, but instead of water, it's a constant stream of tiny, invisible particles, some harmless, some potentially dangerous. These particles can pass through the human body, damaging cells and DNA. Over time, the cumulative effect of this radiation exposure can be devastating. That's what it's like on the moon, radiation-wise. The lack of an atmosphere and magnetic field means there's no natural protection from these cosmic hazards. Future lunar missions will need to develop advanced shielding and protective measures to ensure the safety and health of astronauts. This could include building habitats with thick walls, using lunar soil for additional shielding, or even developing new materials that can better absorb or deflect radiation. The moon's unfiltered radiation is a cosmic hazard that we must overcome to make lunar exploration and settlement a reality. Section 6. Cosmic rays, the silent threat from deep space. One type of radiation that bombards the moon is cosmic rays. These are high-energy particles that travel across vast distances of space, originating from exploding stars and other cosmic events. These rays can pass through spacecraft and even spacesuits, potentially damaging cells and increasing the risk of health problems for astronauts. Section 7. Solar storms, when the sun turns angry. The sun, our life-giving star, can also be a source of danger. During solar storms, the sun releases bursts of energy and charged particles known as solar flares and coronal mass ejections. These solar storms can be dangerous to astronauts on the moon, as they can disrupt electronics and expose them to high doses of radiation in a short amount of time. Section 8. Lunar dust, a radioactive minefield. Even the moon's dust poses a radiation risk. This fine, powdery dust, created by micrometeoroid impacts over billions of years, is electrically charged and clings to everything. This dust can be breathed in by astronauts, and its sharp edges can irritate the lungs. What's more, the constant bombardment of radiation from space makes the dust itself slightly radioactive. Section 9. Shielding our future moonwalkers, a cosmic necessity. So, how do we protect future lunar explorers from this invisible enemy? The answer lies in developing advanced radiation shielding technologies. This might involve using new materials that are better at blocking radiation, designing habitats underground or in naturally shielded locations, and developing early warning systems for solar storms. Section 10. The future of lunar exploration, a challenge and an opportunity. The moon's radiation environment is a challenge, but it's not insurmountable. The harsh radiation on the lunar surface poses significant risks to both human explorers and the technology they rely on. However, with advanced research and innovative engineering, we are developing ways to mitigate these dangers. Protective gear, radiation shielding, and underground habitats are just a few of the solutions being explored to ensure the safety of astronauts. By understanding the risks and developing innovative solutions, we can pave the way for a safe and sustainable human presence on the moon. Engineers and scientists are working tirelessly to create new technologies that will allow us to live and work on the moon for extended periods. From advanced life support systems to efficient energy sources, every aspect of lunar habitation is being meticulously planned and tested. Exploring the moon is not just about pushing the boundaries of human exploration. It's about expanding our knowledge and capabilities. Each mission to the moon provides invaluable data that helps us understand not only the moon itself, but also the broader workings of our solar system. The samples collected by astronauts offer clues about the moon's history and its relationship to Earth. It's about unlocking the secrets of our solar system, developing new technologies, and inspiring future generations. The discoveries made on the moon have the potential to revolutionize our understanding of space and our place in it. Moreover, the technological advancements driven by lunar exploration have applications far beyond space travel, impacting fields such as medicine, materials science, and environmental monitoring. And perhaps most importantly, the sight of astronauts exploring the moon ignites the imagination of young minds, inspiring the next generation of scientists, engineers, and explorers. And that's a journey worth taking, even with the challenges that lie ahead. The pursuit of lunar exploration embodies the spirit of human curiosity and resilience. It reminds us that no challenge is too great when we work together towards a common goal. As we look back at Earth from the moon, we are reminded of our shared humanity and the boundless possibilities that lie ahead. The journey to the moon is not just a scientific endeavor, it's a testament to what we can achieve when we dare to dream big.